I simply can't decide. Oh, I got an idea. Eeny, meeny, miny, mo. Catch a tiger by his toe. If he hollers, let him go. My mother said to pick the very best one. And you are it. You can breathe. You can blink. You can cry. Hell, you'll be doing a lot of that. Oh, look at that. Taking it like a champ. Oh my goodness! Look at this! I could use that. Microwaves are awesome. They're stocked full of high voltage electronics like motors, transformers, and capacitors. But what we're looking at specifically today is the magnetron. A magnetron is a type of vacuum tube that generates microwaves using a magnetic field to control electron flow. It works by using a cathode, usually a filament, to emit electrons when heated. These electrons are then accelerated towards the anode due to an electric field. I could go deeper into how this works, but I'll put a link down below to someone who can explain it much better than me. Using the components found inside a common microwave, I'll show you how I turned it into a microwave gun, meant to disable electronics at range, and how you can defend against it. I'd like to preface this video by saying do not try any of this at home. Although microwave radiation is non-ionizing and relatively safe in amounts explained later in this video, the electronics used in this build are extremely dangerous, with current and voltage high enough to kill you instantly. So let's get into it. If you've never been to college, the last few weeks of the year are the best if you're a hoarder like me. Everyone everywhere is just throwing away their perfectly good stuff, which means I stumbled upon a free microwave. While I was procrastinating studying for my finals, I found a video by Tech Ingredients, linked below, about DEWs, Directed Energy Weapons, and their uses in defense. This weapon was capable of taking down drones and other remotely operated devices. So I wanted to see if I could make my own and test its effectiveness. The real-world application for this technology would be a cheap and readily available defense in situations like what we're seeing in Ukraine. Unfortunately, we see this tech used against people for crowd dispersal tactics known as an active denial system. While its effects are reversible, this weapon causes intense burning pain in the upper layers of your skin. I believe that the use of this weapon against people is not at all ethical, which is why I will also be showing the defense and detection of such a device. So now, I'll get into how I built it. I started by ripping apart the microwave I found, making sure to keep everything connected how it was inside the machine. Reminder, this is dangerous. The only components you need for this are the magnetron, the transformer, that will kill you, the capacitor, that will kill you, the voltage noise filter, a cooling fan, and the power cord. I then transferred them all onto a wooden board. Once everything was secured down, it was time to make the waveguide. Microwaves are unable to penetrate conductive material and instead reflect off. I used the shell of the microwave to build this. Unfortunately, that microwave was underpowered. So I went on Marketplace and found a beefy microwave that was 1.5 times more powerful for $10 and repeated the steps from before. To protect myself from the exposed high voltage connections, I got some thick plastic and constructed a shell around the electronics, allowing for airflow. After adding handles and a switch, it was time to build the defense for it. Using microwave's reflective properties, I secured aluminum screen onto a polycarbonate riot shield using aluminum tape. For reasons I can't explain very well, microwaves are unable to penetrate the holes in the screen because their wavelength is larger than the holes, allowing you visibility and protection from the waves. Now, it's finally time to test it.
You should put a taser on it. You should put a taser on it. Put a taser on it. You should put a taser on it. Sappy. You should put a taser on it. Put a taser on it.
I put a taser on it. There wasn't a whole lot of reason to do this other than it's cool as hell, and I just had the parts laying around. So I hooked up 3 taser modules in parallel and hooked it to a 7.4 volt battery. So, due to the fact that you can't exactly use it in a residential area, I've come out to the farm where we're going to run a few tests. Yeah. The first of these tests is to prove that I'm not harming any wildlife or electronics or anybody else, because you can't exactly use this in a residential area without harming anybody's electronics. We now go live to our reporter in the field. Thank you, Colton. I'm standing here in this field in the range of the microwave. It is currently on, and we are currently reading levels safer than the outside of your microwave while it is running. Back to you, Colton. Thank you, Colton. The microwave detector I'm using is used by professionals to deem if microwaves are safe or not by FDA standards, which means that it needs to have less than 5.0. I don't know what you call those. I'm going to say microwaves per centimeter squared. It's probably not right, but let's see if the outside of my microwave is dangerous or not. It appears that it is not. Although that isn't great, a federal standard limits the amount of microwaves that leak from an oven throughout its lifetime to 5 milliwatts of microwave radiation per square centimeter at approximately 2 inches from the oven surface. This limit is far below the level known to harm people though, so I think I'm fine. That's okay though, because that's what we want. We've essentially made a very leaky microwave. One of the main reasons to build something like this is specifically for aerial defense against drones. So let's try that one more time. There and have it. Come back to me.
Shut up and sit down.
Unfortunately, we've had to start filming with the bad camera due to the fact that conductive material reflects the microwave and will affect the camera. So, as you can see, once it's in front, close, behind, nothing. And you can even see over here by my hand that it is glowing, but once it's behind the shield, it is no longer. If I even twist it a little bit this way, see if I can get my phone. See that even over here, it is reflecting off of the shield this way. Another thing that I put on the shield are these small are affecting them. So as you can see, the camera is completely safe behind the shield. So I know this video wasn't very scientific, but I meant it to be more of a proof of concept towards something bigger. I don't plan on revisiting this project anytime soon, but in the future I'd like to turn it into an automated turret using a Raspberry Pi and AI to detect drones and auto aim towards it. If you stayed this long, please leave a like and subscribe to the channel if you want to see more content.